Okay, Ecotopians, let's figure out what's going on with this science project thing. The deal is that science is a really important part of our society, of your education, and of this class. And so I've built in about a quarter of your grade into this science project, so it's important you understand the global view of what's going on here. Basically, there are 5 different parts that you are going to turn in for a grade. And unless you do really poorly on some part of it, it's you get full credit for everything you submit. So briefly, let me just explain, well, first of all, that everything in this video is in this document that is also on Moodle. So you don't have to listen to this video if you'd rather read, and you don't have to read this if you'd rather just watch the video, though I prefer the written word because the guidelines there just stay. Anyway, it's up to you. Here's what you're going to do. In fact, about in 2 weeks from now, your first part is due, and this part is simply turning in a hypothesis and an experimental design to test the hypothesis. So hopefully you've already read or seen the presentation I made regarding the scientific method in critical thinking, so you have a good background on what to do. And a background on the scientific method. So you're now going to practice it. Number 1, developing a hypothesis and an experimental method to go with it. Those 2 things need to go together. The hypothesis needs to be testable, and your experimental method needs to test it, and must do so in a logical, rational way that will convince other people. So actually, I'll say more about that in a second. I'm giving you the global overview now. So the first part is experiment, hypothesis and experiment. The second part is do the experiment, gather the data, and write it up. That sounds like a lot of work, and it is, and you have some extra time to do that. So I urge you to take advantage of the time given you to do that. Number 3 is publication, and so you'll write up a draft and you will submit that. But publication requires, in the scientific world, peer review. And so I've built that into this class. And so you submit your paper, and your paper will be read by 3 of your classmates, and they will make helpful comments about your draft to try to make it better and get it back to you. You will also be reviewing 3 other papers doing that. You'll be making helpful comments to your peers, and that will go back to them. Fourth part is taking those comments to heart and making revisions and submitting the best possible final paper you can. That then goes to the 5th round, which is sort of mimics what happens in the professional world regarding competition and popularity. 5 papers you will each read, 5 of your peers' final papers, and you will rank them on how well the research was conducted, how well it was written, how interesting it was to you, and so forth. And so that last part is kind of a competition. And after you submit your rankings, which is the last part of your grade, I will choose the winners, and they get a special prize. I don't know what it's going to be, something. Okay, so 5 parts to this assignment. You need to carefully monitor Moodle to know which part you should be working on now, and then how to submit your assignments. So I wanted to give you some guidelines on how to set this up. The first part, which is the first part that's due, and it's 2 Sundays from now. Actually, it's Sunday, April 6th at midnight. Here's some guidelines for doing that, specific guidelines. And again, you can read this, so pay attention. It's the most creative part and the most interesting part of the scientific method is coming up with a question or observing something interesting and developing a hypothesis about it. So you need to look around your immediate environment, inside your house, at your friends, I guess. I don't know if human experimentation is a good idea for this class. In your backyard, and ask yourself, what's going on here? What's interesting to me? What piques your curiosity? And allow the questions to bubble up, and try to design experiments to test any question you might have. Or if you make an observation, say, how can I design an experiment to explain why that happens? Okay, so do that, and then develop the experiment and turn it in. That's all you have to do. but do as good a job as you can so that you're ready to go on conducting your experiment. If you present a crappy experimental design, it's not going to work for you, obviously. Okay, so regarding your experiments, there's two classes of experiments in the world. One is a controlled experiment, and one is a natural experiment. I am not going to explain to those to you here in this video, but there's some links I've put on Moodle to a Wikipedia page which explains them beautifully. So make sure you understand the difference between a controlled experiment and a natural experiment and decide which one you're going to use to test your hypothesis. When you look at those links and you're reading about these, you really need to understand the two definitions of the word control. One is control as a verb, and one is control as a noun. Read those and learn them. Very important. I take those really seriously, and you need to apply those definitions in your experimental method. Really, if you come out of this class understanding the difference between control as a noun and control as a verb, you've gone a long way to achieving the general education requirements of knowing something about science. Okay. Let's see. In this handout, I talk about your experiment must include some sort of a treatment, and 2 or more levels of treatment are recommended, though not required, especially if you're doing a natural experiment. Maybe just 2 treatment levels would be sufficient, but more is definitely better. It makes your experiment more robust. And let's see. I talked a little bit about controls here and replicates, but you can read about that. Okay. Looking ahead, and it's a good idea to, while you're developing your experimental method, to look ahead at how you think you might present this to an audience. For instance, when you gather your data, you want to analyze it, calculate averages, and make graphs. And it's a really good idea to come up with some imaginary graphs that you want to create from your experiment, and then thinking about that graph will tell you that, oh, in my experiment, I need to gather the data that will help me make that graph. So when you write up your experiment, you never give raw data. You never just say, well, here's my data for 1 and for 2 and for 3 and for 4. You never do that. You summarize it. You say the average height of the population that got the drug was this, and the average population that got the other drug was that, or something like that. Okay, so you should calculate and present averages of your treatment level, so plan ahead to do that. And if you want to do other statistics, good on you. It's not a stats class, it's not a robust science class, so I'm not going to have you do a whole lot of crazy statistics, but you should at least be able to calculate averages. Okay, you must when you do your write-up, you must analyze your data logically and relate your results to the hypothesis. So in the end, your peers will be looking at what you say and say, are they being logical? Did they take everything into account? And did they relate the results to their hypothesis? That is, do the results support their hypothesis, or they don't support them at all, or there's somewhere in the middle? And then do they take the next step and say, why might the results have come out this way, and get the most out of the data that you possibly could have? Your analysis in the end must be thorough and must show good critical thinking, and there's a presentation on the scientific method in critical thinking, so review that as you're writing your stuff. Am I being open-minded? Am I seeing both sides of the issue? Am I being logical? And so on and so forth. And I'll say it again, that you must make the most of the available information without stretching it too far. Very often I've seen students, if their results don't perfectly support their hypothesis, they throw the whole thing out and say, this was just a waste of time, this was no good. Throwing the baby out with the bathwater, because sometimes in the data there are some very interesting findings worthy of note, even if they don't wholly support the hypothesis. Furthermore, your results might indicate a new hypothesis. Well, my data do not support this hypothesis, but maybe they indicate something else, and that would be an avenue for future research. So pointing the way to the readers towards future research would be great. Okay, that's all I have to say about this. Think hard, be creative, come up with good experimental designs to test hypotheses, and I can't wait to read about them. Take care.